Alright, so this is number 24 in the exam review for Math 162. That's the second semester pre-calc. The first two videos I did covered numbers 1 through 9 on video number 1 and then 10 through 23 on the second video. So if you're looking for something below number 24, look at one of those videos. This one's going to start at number 24 and it says to expand x minus y raised to the fifth power. So for this one you need to know how to do this a shorter way than multiplying it out. And we learned in class to use Pascal's triangle for that. So to start Pascal's triangle, we start with the 1, and then that's our 0th row. Our first row is 1, 1. Our next row is going to be 1, the sum of 1 plus 1, which is 2, and end with a 1. So the main thing with Pascal's triangle is every row begins and ends with 1, and in the middle you're summing up the numbers above it. So for the third row, I'm going to start with 1, sum up these numbers. Sum up 2 plus 1, end with a 1. Fourth row, 1 plus 3 is 4, 3 plus 3 is 6, 3 and 1 makes 4, end with a 1. 1, 5, 10, 10, 5, 1. I'm just summing up these up above. So this is my 0 row, my first, my second, my third, my fourth, and then my fifth. And so this is what I want when I'm raising something to the fifth power. These will be my coefficients of this expansion right here. So I'm going to write out those coefficients. 1, 5, 10, 10, 5, and 1. And then I'm going to start with my x. I'm going to put him down and say x to the fifth, x to the fourth, x cubed, x squared, x to the first, and then this is like x to the 0 there. Then coming back the other way, I'm going to put my y in and go y to the fifth, y to the fourth, y cubed, y squared, y to the first, and then it's like having y to the 0. Now, because this is a minus, not all of these are going to be positives. So the first term is positive, and then it alternates between negative, positive, negative, positive, and then negative. Now this one's pretty easy because all the coefficients there were either 1 or negative 1. But if it wasn't, if this were like a 2 or something, then make sure you're taking the 2 to the fifth power, 2 to the fourth power, 2 cubed, 2 squared, 2 to the first, and multiplying by those coefficients. Okay? Alright, so for this one it says find the standard form of the parabola with a vertex at 4, 2 and a focus at 4, 0. I think the best thing I can do to just kind of get in my mind what's going on here is to kind of sketch this thing out. And so with the vertex at 4, 2, it's going to be somewhere up in here. That's where 4, 2 is. And notice the focus is at 4, 0. So remember with parabolas, let's say it's facing up, the focus is on the inside of that parabola. If it's going to opening up to the right, once again the focus is on the inside. Well, the focus they're saying is at 4, 0, which is going to be right here. And so this is what we're looking at. So it's got to be pointing downward. And I know it has a vertical line of symmetry right here. And then it's also going to have a directrix somewhere up here, probably at 4, 4, like that. And I notice this distance between the vertex and the focus is going to be going down a -2. So that's going to be my p-value. And so because it's got that vertical axis of symmetry there, it's going to tell me to use x minus something squared, and that h, well, I'll go and write out the general equation is x minus h squared is equal to 4p times y minus k. And so the x minus h, remember that the vertex here is hk, and I already found my p-value, it's -2, just by counting down how far away the focus is. Remember, that's the distance from the vertex to the focus is your p-value. Since it's going down, it's going to be a negative p-value. Putting -2 in for p, you get -8. And then y minus 2, because we substitute in our k value of +2. And then we get x minus 4 here by substituting in our h value of 4 right there. Now, this should make sense because it's negative. We know that it's going to open up downwards. And then we've got our center here at positive, or not our center, our vertex at +4, +2. Okay? Next one says, find the standard form of the ellipse with vertices at -3, 0, and 7, 0, and foci at 0, 0, and 4, 0. So pause the video and start by sketching this thing out. So all I've done here is just sketch the points that they gave me with my two foci right here in the middle and the vertices on the outside edge. Now remember, the standard form for this looks like we're going to have a major horizontal axis here. So for the major horizontal axis, we're going to have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the only difference is if it were going vertically over here would be to put the a squared underneath the y minus k part there. Now a couple of things with the a, b on here. We know h and k, they have their special points, but that's the center of it, which is going to be halfway between the endpoints. But a and b go from this, the center out to the edge. That's going to be a, and b is going to be your minor, I guess you could call it your minor axis right here, going from here up to the top. So let's go ahead and identify our center, our HK. So how long is it from one point to the other? You could say, what is 7 minus a -3, and that would give you 10. And you can count them if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could find the midpoint between these two. That would work. 7 plus a -3 gives you 4, and so you get 2, 0. Or you can just count from the edge, 1, 2, 3, 4, 5. So a lot of different ways to find out that 2, 0 is your HK in this point. And so we already know that's going to be x minus 2 squared and y minus 0, which is just y squared there. But I still need to figure out what a and b are to finish this thing out. So the length of a we can just count is 1, 2, 3, 4, 5. So that's going to be 25 there. But how do we figure out b? So remember, I know that this right here is a, and the distance, remember, from the center to this focus right here, we call that c. And so if you were to slide a up, if I were to take this blue line right here and slide it to c and point it up, I would have a triangle that kind of looks like this, where this is b, c, and a. And so using the Pythagorean theorem, we'd have b squared plus a squared, not a squared, plus c squared equals a squared. And so we want to solve for b here, so we end up with b is equal to the square root of a squared minus c squared. And so I know that c squared right here is going to be 4. And a squared is going to be 25. So I get the square root of 21 is equal to b. So b squared here is going to be 21. And so that's all this question is asking for here, is just what the standard form is. And so you need to know whatever this b distance is, square root of 21, it's going to be between 4 and 5. So if we go up 1, 2, 3, 4, there's 5. It's going to be somewhere right in there. Same thing going down, 1, 2, 3, 4. So our ellipse is going to look something like this. Just remember, if this is C, this length right here is B, and then this is the same length as A. So if you were to take this piece and slide it down, you get the same length right here. But if you can draw it out like that, even if you can't remember this equation, you should be able to draw it out and solve it from there. And so what I want to do here is first identify my HK. In the equation, we have x minus h something squared in the numerator plus y minus k squared in the numerator equals 1. Now, go ahead and identify what your a squared and b squared are. I know that the square root of 100 is 10, so this is like saying 10 squared. Square root of 81 is 9, so it's like saying 9 squared. And so obviously my a is right here, so a is equal to 10 and b is equal to 9. Remember, we want the bigger number is going to be the a when we're talking about ellipses here. So what did I put in for k to get a -1? I must have put in a +1. And what did I put in for h to get a +2? It must have been a -2, because -2, or x minus a -2, is going to become x plus 2. And so my center of this ellipse is going to be at -2, +1. And then I know that b is equal to 9, so I'm going to go 9 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 this way. I'm going to go a little bit off the graph there. And then I know that my a is 10, so I can go down 10 this way. 10 up. It's going to be a little bit off the graph this way, and my ellipse is going to look something like this, which is horribly drawn by hand. It should look something like a warped egg, or football, I guess you could say. Now it says to note the center, so we've got this right here as our center, so we might as well put that down, equals the center. The vertices, so we know the vertices are going to be where a is, so we've got 10 below +1, which gives us -9. So it's going to be at -2, -9. And then your other vertice is going to be 10 above that +1, which is going to give you -2, 11. Remember, with the vertices, we're only talking about on the A, which is the longer side. I'm just going to erase that because that looks awful. Not on your 2B side. So it's only these points right here on the longer edge, the tips of the football, if you will. So that's your center and vertices, but it also says to take notice of where the foci are. So we need to be able to figure that out. And remember, they are C distance. Here's our center. They are C distance away from the center. So remember what we said on the last problem over here. We said that b squared plus c squared equals a squared. And we're going to follow that rule again, where we have b squared plus c squared is equal to a squared. And so substituting what I know in there, I've got 9 squared is 81. This is 100. And so you get c squared is equal to 19, where c equals the square root of 19. A good way to remember this is you always just take this one minus this one, the bigger number minus the smaller number, and then square root it. That will be c every time when you're talking about ellipses. And so from here, this is the center, and I know that's at -2, 1. So I'm going to say -2, 1, put a 1 in there, plus the square root of 19 will take me up to where I need to go for the first foci. Now, square root of 19 is going to be between 4 and 5, because the square root of 16 is 4, the square root of 25 is 5, so it's actually a little bit closer to 4. So I go up 1, 2, 3, 4, and just a little bit above it. That's where one focus is going to be. And the other focus is going to be 1, 2, 3, 4, and a little bit past it down below. So this is the first one. That's my +1. And then my other one's going to be at -2, 1 minus the square root of 19. That's where the other focus is. So those are the location of my foci. And you can write it all in one if you want. I think the answer key I've got is plus or minus the square root of 19, and that'd be fine. The next says graph the conic 9x squared minus 16y squared minus 18x minus 32y minus 151 equals 0. Note all the same things there, including asymptotes if there are asymptotes, if it's like a hyperbola or something. So first thing I want to do is make this look like a standard form, not the general form. And to make that happen, I'm going to first pair up my x's. So I got 9x squared minus 18x. I'm going to pair up my y's. So I have negative 16y squared and then minus 32y. I'm going to go ahead and move that 151 over. I don't want him with any of those things. And with this, I'm working towards being able to complete the square. So in order to do that, I'm going to go ahead and factor out a 9 here. And so when I factor out a 9, I get x squared minus 2x. I'm going to leave some space to complete the square there. And I'm going to factor out a negative 16 over here. And that leaves me with y squared plus 2y. Leave some room to complete the square over here. And that all equals 151. Completing the square here, I'm going to take half of negative 2. That's going to give me negative 1 and square it. That's going to be a positive 1. But remember, I'm not just adding 1 to the left side here. If you distribute the 9, you're really adding 9 to the left side. So I need to add 9 to the right side. Over here, half of 2 is 1. Squared is 1 again. But what I'm really doing is subtracting 16 when you distribute that negative 16. So I need to subtract 16 from the right side also. And so x minus 2x plus 1, that's the same thing as x minus 1 quantity squared. And y squared plus 2y plus 1, well, that's the same thing as y plus 1 quantity squared, and the negative 16 out in front. Adding 9 to this, I get 160. Subtracting 10, I get 150. Subtracting another 6, I get 144 right here. And now if I divide both sides, remember with the conics, typically if you're talking about an ellipse or a hyperbola, you're going to want a 1 over here on the right side. So go ahead and divide both sides by 144 to make that right side 1. And if you did everything right, hopefully you get something nice and pretty when you divide these two terms by 144. So if you notice, 144 divided by 9 is 16, so 9 over 144 is going to reduce to 1 over 16. So you get x minus 1 quantity squared over 16. And then 16 over 144 is going to give you 1 over 9. So you got minus, because of that minus in front of it, y plus 1 quantity squared over 9 equals 1. Let me see if I can bring that equals 1 down a little bit so it looks a little bit more like an equation there. And so now we have, think about it, is this an ellipse or is this a hyperbola? It's going to be hyperbola because you get that minus sign in there. All right, and so now the rest of this question just deals with where's the center? Well, we know the center is at 1, negative 1, because I must have put in positive 1 to get minus 1 for my h, and then negative 1, because y minus a negative 1 gives me positive 1 there. So that's your center. And then you have to identify the vertices. So I think it's kind of easy now to kind of graph this thing. It does tell you to graph it anyway, but kind of graph it while you work it. It makes it a little bit easier. Go ahead and graph 1, negative 1 right there. And we know that this is going to be opening up horizontally like this. And the reason why is your bigger number is underneath the x's. And so you know your a value is 4. It's going to be the square root of this number right here. The square root of 16 is 4. So go over 4. 1, 2, 3, 4. And 4 this way, 1, 2, 3, 4, and that's where your vertices are. And so where is this? This is at 5, negative 1, and then at negative 3, negative 1. Those are your vertices. And then lastly here, we need to figure out, well, not lastly, we still got to figure out the asymptotes, but we got to figure out the foci. And so I know it's going to be curving around like this and like this. Let's figure out where that foci are. All right, I just cleared a little bit more way out of here so we can figure out the foci is going to be c distance away from the center again. So this one's a little bit easier. Remember, it's the same thing as the Pythagorean theorem to help you figure out what c is. So I know my a is the square root of 16, which is 4. So 4 squared plus your b squared, which in this case is going to be 3 squared, is equal to c squared. So in this case you're going to have 25 equals c squared, so 5 is equal to c. So if you start at the center and count out 1, 2, 3, 4, 5, that's where one foci is, or one focus is. If you go 5 the other way, 1, 2, 3, 4, 5, there's your other focus. And so our foci are going to be at, let's see here, this is at 5, negative 1, it's going to be at 6, negative 1. And the other one's going to be negative 4, -1. This right here is where your foci are. And then lastly, we need to write out the equation of the asymptotes. So for that one, we need to, it kind of helps us to draw this box, I think. And so we need to know where is B on this graph. We know that B is equal to 3. So if we go up 3, 1, 2, 3, and go down 3, 1, 2, 3, we can form this box that kind of looks like this. Oops, horrible at drawing vertical lines today. Let's see. And so our asymptotes go through the corners of this box right here. So they go through just like this and just like this. And so here's where it's nice to be able to use point slope form of a line. Because with point slope, I can use my center as the point, and I can use my slope right here that you look at. It's B units up and A units over. So your slope is B over A, in which case is 3 over 4 is your slope. And a point that's on the line is the center right here, 1, -1. So the equation of one line, if you think about point slope form of a line, you got y minus something is equal to your slope times x minus something. In this case, our y minus is going to be this y value right here, which becomes y plus 1, and this one becomes x minus 1. There's the equation of one line. That would be this positive slope line. This right here is the same slope except for it's a different sign, because remember you're falling 3 and running 4, so it's going to be -3/4. You can use the same point. That'd be fine if you put plus or minus there. That would work also. But here's the equation of the other asymptote. So here's your two asymptotes. So to finish out the graph, with the asymptotes drawn and the vertices drawn right there, I'm just going to keep it really close because we know it heads out towards this thing. It's going to come in, hit your vertice, and then go out towards that way up there. Same thing on this side. It's going to come in really close. Whoops, not touching it, but really close, and then curve away like this. And that's how we graph that thing. So use those lines, use your vertices, be able to find all of those things, and you should be fine with those topics. Next one says, a parabolic archway is 8 meters high at the vertex. At a height of 6 meters, the width of the archway is 8 meters. How wide is the archway at ground level? So the first thing I want you to do is sketch this thing out. So go ahead and give that a try. So for this one, this is the best I could sketch it out. It almost looks more elliptical than parabolic, but just, you know, maybe you're a better person at sketching these things out than I am. Just realize it's not that, it's a parabola. And the approach I would take to a problem like this is to first see if you can find the standard form of the equation of this parabola given what you have here. So you can kind of create what you want. I'm going to call this right here the origin of the graph. So this is at point 0, 0. And what makes this nice is now every other point can be referenced to this one right here. For instance, the vertex becomes at 0, 8. So this is my HK. Already I've got that down. And then I know if I go, the whole length of this is 8. So really it's like this side is 4 and this side is 4 also. So this point right here is at +4, +6. Once again, it's not drawn to scale. Obviously 6 is bigger than 4. And this is -4, +6 also. And so that can help me as well. And what I want to know is when this position right here is at 0, what is my x coordinate? And the same thing right here, this is going to be at 0, what's the x coordinate right here? Or I can just say, once I know x, I can double it since the axis of symmetry is coming right through here down the y-axis. And that will give me the total width. So that's the ideal. See if you can pause the video and take it from there. If not, just give it a try for about, I don't know, a couple minutes and then watch the rest of the video. So I know the standard form of a parabola here is going to be, if it's a vertical axis like we have, is x minus h squared is equal to 4p times y minus k. And so I have my hk here. It's at 0, 8. So this gives me x squared is equal to 4p times y minus 8. And I can also pick any point on the parabola and call it x comma y. And so substituting that in, I get 4 squared is equal to 4 times p times 6 minus 8. This gives me 16 is equal to 4 times p times negative 2. And I get negative 8 times p is equal to 16, where p is equal to negative 2. So that's just substituting in what I know. That gives me the p-value, and that tells me that my standard equation here is going to become x squared equals 4 times negative 2, which is negative 8, times y minus my k value. I know the k value, it's 8, right? So here, let me erase that. I can put minus 8 in right there. And now I can solve this thing for x by substituting in 0 for my y. So let's erase some of this stuff over here on the left now. And so if I put 0 in for y, I can figure out what x is equal to. So x squared is equal to negative 8 times negative 8. Negative 8 times negative 8 is positive 64. So x squared equals 64. So x's value is plus or minus 8. So this is at negative 8 comma 0 and 8 comma 0. And so how wide is it the ground? At ground level, it is 16, and is this in meters, I believe, 16 meters wide. So this is 8, and this is 8. This whole thing right here is 16. For these next two right here, we want to identify the conic. And so a couple of things to keep in mind when we're looking at this general form of we got something like ax squared plus cy squared plus dx plus ey plus f equals 0, then we can do a few things and say that it's a circle if a is equal to c. It is a parabola if AC equals 0. It's an ellipse if AC is greater than 0. And it's a hyperbola if AC is less than 0. I don't know why this keeps leaving random marks here. Let me erase those. That bothers some people there. And so remember that that's in the general form of ax squared plus cy squared plus dx plus ey plus f equals 0. So we're really just concerned about the coefficient in front of the a and the coefficient in front of the y. That's all we're looking at. Are they equal? And then if they're equal, we know it's a circle. Do we have that already? Look in front of the x squared and y squared terms. Well, in front of this one it's a 1, in front of this one it's a 4, and so they're not equal there. So we know b is not going to be a circle. Look in front of this one, negative 4, and there is no, it's like saying, in this one, it's like saying 0x squared right there. And so those aren't equal, so it's not a circle. We can rule out circle as an option for both of these. And then now look at the product. What do you get when you multiply the product of the y squared, or the coefficient of the y squared term and the coefficient of the x squared term? So 0 times negative 4 is what we have here. That equals 0. And over here we're going to get 1 times 4. That equals 4. So if it equals 0, we know we're dealing with a parabola. So letter choice A right here, it's a parabola. Now if we go to the next one, we've got, it's not equal to 0, so that rules out parabola. It is bigger than 0 though, so that leaves us with an ellipse. So looking at these rules right here, hopefully the circle comes off as pretty easy, and so does the parabola, because usually we've got one term that's squared and the other's not squared. We know we're dealing with a parabola. If they're equal, we know we're going to be dealing with a circle there because of the equation of a circle, the way it works out. But it's also helpful just to kind of memorize this list. It makes it real short and easy to figure out which conic you're dealing with. Next one says plot the point 3, 2 pi over 3 in polar coordinates on the plane, then change it to rectangular coordinates. So first thing I want to do is come out 3 units. So I'm going to go out 1, 2, 3, and then that's my radius. So it's going to be somewhere along this circle right here with a radius of 3. And then I want to go out to 2 pi over 3. Now this graph I've got here is marked in degrees, so they could have done it as 120 degrees, but they do it in radians. And so we know 2 pi over 3 is the same thing as 120 degrees. So you go out 1, 2, 3 on the 120 degree mark. I need to grab a line right there. And there's the point we're talking about. And now we want to change that to rectangular coordinates. And so remember, with 2 pi over 3, what's that triangle look like? If you're talking about the unit circle, it would have a radius of 1, and so the hypotenuse would be 1. This right here would be, let's see, we're talking about a tall angle there, that'd be negative 1/2, and then this would be positive square root of 3 over 2. But this triangle, since it has a radius of 3, is 3 times as big as that. So if you multiplied all the sides by 3, you'd end up with this side right here being 3 square roots of 3 over 2. This side being 3 still, and then this side would be negative 3/2. And so we're wanting to know how far over do you come and then how far up. We're going over negative 3/2. And then we're going up a positive 3 square roots of 3 over 2. And so this is our rectangular coordinates for the same polar coordinates there. Now, for the graph of e to the x, if you don't remember what exactly it looks like, you could make a chart. And so you could bring out your value of x and e to the x. It's not too much different than other things like 2 to the x, 3 to the x, 5 to the x, 100 to the x. It's good to be familiar with what all of these look like. So let's switch over to Desmos and see exactly what these things are looking like. So here we are on Desmos, and if you just type in any of these things like 2 to the x, that's what your graph looks like. Let's go down and put in another one like 5 to the x. Boom, there you go. Second ago I said 100 to the x, so let's look at that. 100 raised to the x. There you are. And then we got e to the x. Let's go and put that in, e to the x. So e is just another number. 2.7, blah, 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 and it's drawn right here in orange. But notice all of them. It's like they're a bunch of strings. They're being wrapped around this point right here, 0, 1. And that should make sense if you put down in a table right there 0. Anything raised to the 0 is 1. So at 0, these should be crossing at 1. So I'm definitely looking for that when I check your work. The next thing you notice is the range on this thing. And the range is all positive values. But it's not equal to 0 or any negative values here. And so I should see something like, even if you go into right here and zoom in on the graph, it never does quite approach 0 because there's nothing I can raise this to the power of that will give me 0. And so as we go to negative infinity right over here, like if you raise it to the -7, like 5 to the -7 is the same thing as 1 over 5 to the 7, which is a really small number. So these numbers get really, really small as you go to negative infinity, and right after you cross 0, they get really high really fast. They go up really steep. So I should definitely see this general shape on any of these that you graph, and I should definitely see it going through 0, 1, and not going into the negative realm, not unless we do some type of transformation to it, like if we were to subtract. So if we subtracted 5 from it, then we can see it going down below. That's because you've got that transformation stuck on the end, shifting it down 5. All right, so our graph of e to the x, let's go ahead and see that again. We're going to close out these. Should look like that right there. The next question asks you to graph the natural log of x. And so remember that these exponential functions and the logarithmic functions, they're inverses to one another. Think about what that means graphically. Graphically, it means if you were to draw the line y equals x, so if we have y equals x right here, it's a reflection over that line. So if e to the x is drawn in orange, then our natural log should look like we folded along that purple line there and got something else out over there. So the natural log of x, whoops, not 9x, natural log of x looks like this right here. It should be the inverse of this one. Now, something to take note of right in here is that it goes through this point right here, 1, 0. And if you think back to your geometry days when you did reflections over y equals x, you switch the x and the y values. And so that's what's going on right here. Remember, this one we went through the point 0, 1. Now we're going through the point 1, 0 because you're switching the x and y when you reflect about y equals x. Some other things to take note of here is that this is approaching 0 but never quite reaching it. Remember, it's the reflection of the orange function right here over this line. And then it's going to gradually get larger and larger as it goes to positive infinity again. Some other things to take note of is, what if we had log of x? What does that look like? Or let's try log base. I mean, you choose the base here. Well, you can't choose the base because this is recording. But if I made it log base, I don't know, 5 of x. Let's see if we can do that. There's log base 5 of x. Let's do log base 100 of x. There's log base 100 of x. Notice once again the pattern here. They're like being scrunched right in here because their inverses were also being scrunched in right here. And so once again, the range on the, not the range, but the domain this time, because we flipped it over this purple line, the domain goes from anything bigger than 0 to positive infinity. It doesn't go into the negative world, not unless we apply once again a transformation of some sort to it to shift it over. But this isn't being shifted, and it all goes through the 0.10. So when you graph these things, I'm expecting them to go through the 0.10 if it's a logarithm, and then through 0, 1 if it's an exponential. But the natural log we see a lot in calculus. That's why we're telling you in this review to take note of where the natural log, the way it's graphed. I don't expect, say, the 0.3.02, 1.105 to be graphed, but I do expect to see this shape. I expect to see the domain and range correct, and I expect it to go through the 0.10. Just like I do for e to the x, I expect it to go through 0, 1, and to see this general shape here. Okay? All right, number 34 says, know how to evaluate the difference quotient. And so here's our difference quotient. Now, it doesn't give you this function right here. This is just one taken out of the book. And so I'm just going to show you how to use it just with this function. It could be any function, though, but the general idea is you should be able to take any type of function for the f of x and substitute it in here and figure out what you got going on. And so remember what I said, that when we have something like this written out, go back to whatever it's defined as, the function of x is defined as, and wherever you see an x, put a set of parentheses in. So that's what I'm going to do here. I've got the f of x plus h, so I'm going to first write out the function f of x with parentheses where I see an x. And so that's the f of x written out. And then I'm going to put in x plus h wherever I see the parentheses. X plus h, x plus h, and that's it for the f of x plus h. And then I'm going to subtract from that the f of x. So in here, once again, I'm going to write out the f of x again with parentheses wherever I see an x. Oops, not a plus symbol, but a minus symbol. And I'm going to substitute whatever's written in right here, which in this case is just x again. So really it's just, I could have just written out the function. And all of this mess goes over h. And so now it's just a little bit of algebra work here. X plus h squared is what I'm going to do first. And I know that that's the same thing as x squared plus 2xh plus h squared. I'm going to distribute the negative 4, so I get minus 4x minus 4h plus 7 minus, now this one there's not really any work that needs to be done other than distributing that negative to each term. So I'm going to say minus x squared plus 4x minus 7, and all of this mess is over h. Now as I go through this, I'm just going to go ahead and cancel out things now while I can, and then I'm going to write things down below. I'm switching colors just so it kind of, all this stuff is kind of written all in black, and so it kind of gets confusing after a while. So I got a positive x squared and a negative x squared. They cancel each other out. I've got 2xh. Nowhere in here do I have an xh term, so I'm going to write that down below. 2xh. And I'm just going to scribble it out so I don't forget that I've already accounted for it. I have a positive h squared, and nowhere up here do I have a positive h squared to go with it. I've got minus 4x and plus 4x. Those will cancel each other out. I've got minus 4h, and there's nowhere that that pairs with. And then plus 7 and minus 7 will cancel each other out as well. And all of this is over h. And so right here I'm going to factor out an h. And so factoring out an h, scroll this down, gives me h times 2x plus h minus 4 all over h. The h's here cancel, and I'm left with 2x plus h minus 4. And this would be our answer if we're talking about this right here as being defined, or f of x being defined as that right there. Now, I'll probably change this function up on you on the final because I'm not going to just give you the answer, but you should be able to substitute these in and evaluate the difference quotient like that. Okay? I know this video went a little bit long, but you're probably just skipping around to the answers you need to know anyway. Otherwise, if you're watching all of these, which is almost 2 hours worth of watching, if you're following along, you should do great on the exam. So thanks for watching, and good luck on the final.